Hello everyone. Through this video, I will explain about the light detector circuit. To do that, I will use the condition transistor work as a switch. Before going to the circuit operation, we need to understand about the light dependent resistor, which is called as the LDR. Here is the packaging of the LDR. It consists of ceramic body, two electrodes, and the photoconductive material. So here is the variation of the impedance as a function of light illumination. So we can clearly see that when the lights goes high, impedance of the LDR goes down. When the lights goes down, the impedance of the LDR goes high. The conclusion is that the impedance of the LDR is typically inversely proportional to the light. For easy understanding, we can use light goes high, LDR goes, RLDR goes low. Light goes low, RLDR goes high. Here is the simple schematic of the light detector circuit, which consists of RLDR, two resistors, and the one LED, which indicate whether the circuit operates at the light or dark, and also the NPN type process, which is work as a switch. So by using the voltage divider rule, this rule I have already explained in my previous video. So according to the voltage divider rule, we can express the voltage of VBE, which is VBE max, by using this equation. And another thing is when the transistor works as a switch, the condition for the VBE, it should be greater than zero point 0.7, especially this is for the silicon. Now we are going to add the condition, which has two conditions, light and dark. First, I'm going to add the light condition. Here is the light condition. Light goes high, RLDR should goes low. For easy calculation, I'm just use the low mean 0. So by adding RLDR 0 here, so we can finally obtain the VDE max equal to VDD. So in here 0, then what happened? RE and RA, it will be cancelling out. Then finally VDE max equal VDD. So normally VDD is around normally VDD equal around 3 volt, which is greater than zero point 0.7. So what happened? Now the transistor is turned on. So there will be IL current that will flow through the resistor and the LDR, then end up with the ground, which means that the LED is now working. So during the light condition, LED is glowing. So not only the light condition, and also we need to check the dark condition. So during the dark condition, we know that lights goes down, RLDR should goes high. So now the high means that the boundary, I just use the infinity. So what happens in any number divided by infinity, the answer is always 0. So now VBE max equal 0, which means now the VBE max less than zero point 0.7. That gives the transistor T1 is turned off. There will be no IL current. In that case, the LED does not work. So the conclusion, during the dark condition, LED is not glowing. So now we can confirm that this circuit can works at the light, which means the light detector circuit. So now we can go through some experiment video.